It's 9:35, and I'd like to call to order the meeting of the Building and Operating Committee for Thursday, May 23rd, 2024. Before we begin, please note that the meeting is being recorded, even though we don't have any speakers here. Any microphones for us. It is being recorded. So welcome to everyone joining us here today in person, as well as anyone who's on the phone. If you'd like to provide public comment at today's meeting, if you haven't done so already, please let Thomas in the back of the room, Thomas, raise your hand, or Justine on the call-in line know what items you'd like to speak to. Madam Secretary, would you please begin by calling the roll?
Thank you. I'm going to be calling the committee members, starting with Director Conroy. Was absent. Giudice?
Here.
Maston? Absent. Parr?
Present.
Rabbit?
Here.
Theriot?
Here.
Vice Chair Rodoni is absent. Chair Garbarino is absent. President Cochran?
Here.
Thank you. You have a quorum of the committee. You're not a committee of the whole. Also, we have Directors Hernandez, Hill, and Thier in the room. Would you like to appoint them?
I would. If the three of them would like to join the committee, I'd love to appoint them as committee members.
All right.
You notice how far down the list they had to go to get a chair today. So welcome to the committee. If you want to check the page numbers as we go through in the bottom right-hand corner, our first item of business, and actually one of our main items of business, is to ratify the authorization of landing rights agreement, license to land at Port of San Francisco Piers, license number 16909, and Mike Hoffman, who's the Deputy General Manager of the Ferry Division, will join us and explain it to us.
Thank you, Director Carr, and good morning, members of the committee. In June of 2021, during a routine inspection of the San Francisco Ferry Terminal, cracks were identified at the District San Francisco Ferry Terminal under berth that compromised the structural integrity and prevented us from continuing service on that berth. The following month, similar structural cracks, although not as significant, were identified on the inner berth that also rendered that berth unusable to our ferry service. So at that juncture, our only option was to utilize the Port of San Francisco's property at Gate B for landing our vessels. And at that time, the district did have a landing rights agreement with the Port for China Basin for Major League Baseball and professional service, but it did not have an agreement that specifically called out Gate B. So the terms in July of 2022, the district signed a new landing rights agreement that included the use of Gate B. And the terms of that agreement, the contract schedule for passenger fees that required the district to pay the port 63 cents per passenger. At the time of the agreement, signing, we were still trying to claw back ridership from the COVID-19 pandemic and didn't have a good idea or forecast of what our future ridership numbers or timeline for return to service at the inner or outer berth would be. So today the inner berth is back in service. The outer berth is still out of service. All of our large ferry service goes to the inner berth, while our Tiburon, Sausalito, and Angel Island service goes to San Francisco Port's Gate B. The good news is we've seen a strong return to recreational ridership in our Sausalito and Angel Island services. And this has resulted in landing fees to the port under this agreement that will exceed the general manager's signing already of $250,000, and we forecast that we see that over this coming summer. So staff is recommending the board ratify the act of the general manager signing this agreement with the port. And I will say again that this is good news that we're bringing this item forward because it is a reflection of solid ridership numbers in Sausalito, Angel Island, and Tiburon. That concludes my presentation, and I'll remain at the table for any questions.
I'll just add one thing. So Gate B is owned and operated by the Port of San Francisco. So the cost of the development of Gate, more importantly, the cost of periodically dry docking it, repairing and maintaining it, or cost that the port recovers through a sinking fund it has set up through those that use the gate, and that's the 63 per passenger charge that you hear about. Is that every year they gotta untie the thing, haul it off, take it to a dry dock, take it out of the water, repairs. You hear we bring vessel repair items forward after dry docking, so sometimes the cost can be pretty significant. So the intent is to cover the port's costs. And as Mike said, the reason we do it is ridership's coming back on the recreation side faster than anticipated. So we thought when we signed the agreement, we'd be okay for years. And it's probably good that, we're back here.
Director Terry.
I was just curious, what is the rationale for basing the cost on the number of passengers rather than on, say, number of dockings?
I think the intent was multiple ACs use this dock. It's not exclusively used by us. And so they wanted to find a way to capture that seems fair, striking a balance. Some people have small boats and do more trips. Some people have big boats and do fewer trips. We're that latter person. But so I think they tried to come up with something that seemed to be fair. And the thought was prorated over the number of people that actually step onto the float. That was kind of the rough logic. There's lots of ways you could have done it.
Yeah.
We have asked the port if they'd be willing to enter into a long-term agreement where we would take over assumption of gate fee. We've said we'd be interested in coming to this board if they were willing to have like a 20-year lease where we're the primary tenant for gate fee. We would be responsible for dry docking, and then we could charge others a similar nominal fee to maintain it. So we have had some conversations. We're not sure if that's ever going to go anyplace with the board.
Director Ryan.
Well, to that end, and it was odd, the 63 cents per passenger. Have we ever done analysis of what the all-in cost of our facility is? And divided a passenger, I'm just wondering.
The intent of the port is to break even on the deal, and it really depends on ridership. We know it's expensive to maintain leases. Our interest in doing a long-term lease on it is just for control of the facility. Because as ferry ridership grows, we want to make sure there's always a place for our boats to tie up there. Right? We have our facility, but if things grow, our facility may not be adequate, plus large upcoming projects on our facility to replace our antiquated facility with something more modern, and having a facility that is there would be helpful. But have done some costs. I think our cost is in the report what we anticipate per year. And, it's 6 figures, but it's not surprising in light of the fact that we're the primary user of it today. We don't use it extensively before until they've built some new facilities a little bit to the south. We're the primary user, but there's a couple other folks that use it also.
I just want to add that when we do see the outer berth, when engineering makes the repairs necessary out there, we'll still have a business need to be utilizing gate fee. When we, especially in the summer months, when we load 100+ bikes out of Sausalito on the main deck and trying to get them off the second deck at our terminal on the second deck, it's very challenging. We can do it, but using gate fee is much more advantageous to us instead of product to our customers.
So we'll be using it a lot less. But then when we have a construction project in a couple of years, we'll have access to it.
And this particular agreement we're doing today is for only 5 years, correct?
That's correct. We would love to have a long-term lease.
Thank you, Mike. Do you want to hang on here just a minute, see if there's anyone in the room that would like to speak to this item? Justine, or who's with Justine today?
Justine, do we have any other speakers on this item?
We have no other speakers on this item.
All right.
All right, thank you. Are there any other questions from the committee?
Move approval.
Thank you, Mike. I have an approval. Do I have a second?
Second.
I have a motion and a second. All those in favor, signify by aye. Those opposed? Thank you again, Mike. The next item is a status report from the board appointee on Summer Marin Area Transit Board. You may have noticed that Patty is not with us today, so that falls to David and me. We have a little show and tell. I'm always taken by the new things that are happening. We have some business too, but let's start with this part. If you look on page, the one that's labeled page 15 at the bottom, it says new pathway counter in San Rafael. How many of you have actually seen a pathway counter and knew that that's what it was? I figured Mike would, maybe Bert. I had never seen a pathway counter. So when they showed a picture of the new pathway counter, you see on the left there. At one point in time, we actually had people sitting there counting in the beginning. So I was excited to be the pathway counter. So I'm sharing that piece of information with the rest of you. The second one is just a fun trolley that goes to Santa Rosa. It's in the Santa Rosa downtown district, connects Railroad Square and downtown district. It's sponsored by Sonoma Clean Power, City of Santa Rosa, Visit Santa Rosa, and SMART. So if you're ever there, the parameters of it are down here, when it runs and what the hours are. And it's free. And it's electric, and it's ADA accessible. All right, if you turn the other page, we have another shuttle. This one's called the River Shuttle. It's majorly sponsored by Sonoma County Regional Parks. But SMART also supports it. And you'll see here, we offer one direct ride to Steelhead Beach in the morning. How many of you have ever been to Steelhead Beach? Oh, good. I was gonna say, if you haven't been, perfect opportunity. We're trying to get people out and around and learning about SMART. And last but by no means least, we are now trying to address what seems to be everyone's concern about the connection between the SMART train and the ferry. We now have plans, is that the way to say it? We now have plans to offer a shuttle service between the SMART train and the ferry terminal. Here's when it's happening: soft launch in June, ribbon cutting. If you're not busy, come on June 20th. It doesn't serve every day; it's mostly weekends. TAM has put quite a bit of money in, the Transportation Authority of Marin. I think that SMART is also supporting it monetarily, and I have a feeling that Golden Gate Bridge will be able to support it. I knew he'd say no.
Wow.
I knew he'd say no. We already talked about that.
That's how you play fun.
But Golden Gate Bridge is a part in it, so I have to give the bridge credit for that, and I really appreciate that as the SMART.
We get 63 cents per passenger.
Yeah. Let's do that.
The TAM money will pass through the Bridge District. SMART's not an eligible recipient, so the Bridge District has graciously offered to receive the money legally from TAM and forward it to SMART.
Nice.
And we appreciate that. Director Hill, did you have a question?
Is it going to be autonomous?
No.
You know what? We'll take it just one step at a time. It was autonomous when people were walking and they weren't excited about it. So, okay. The rest of the general manager's work is, of course, ridership is up. It's over 33% over pre-COVID. The average weekly is up 23% over COVID. We're always in construction. People see us as a train, as a transportation agency. We are, but we're still a construction agency. We have lots of construction going on. Specifically, McDowell Boulevard, we're putting in the conduits for the traffic signs. Petaluma North, we're doing concrete for the platforms. And Windsor, we have an agreement with the city of Windsor to do some extra work at their expense for an undercrossing so that they can put some of their utilities, I believe it is, under there. So those are the three major projects right now. We also had an FTA triennial review. Maybe David remembers the exact number, but it was something like we pulled together 608 documents for the review and passed with flying colors. So congratulations to the organization for that. That's what I have. David, do you have anything else?
And I think the ridership is interesting because, to be honest, right, we broke the all-time, in our 7th year, broke the all-time annual ridership record with 2 or 3 months to go in the fiscal year, which is, so that's a great thing. And it's really primarily, to be honest, about the free ridership to seniors who have been flocking on the train, so but a good service. And it honestly goes to show you that if you have a low fare box recovery, you have more flexibility in how you can operate your system. To be honest, and the sales tax is really the primary mechanism. So it does have that flexibility, and I think we took advantage of it, and that's a good thing. And I do think that Eddie is still, and the board is still cognizant, just like this board, of the changing commute patterns and the recreational opportunities like the seniors are using now because they're on there during the middle of the day going up to lunch or whatever. So that's a good.
And if you would like a copy of what they call Smart Connect, which is our newsletter, it's amazing advertisement for the North Bay and how you can use transportation to get to the various venues. So if you want that, let me know and we'll get it to you. So thank you for that. Any questions or comments? Holly?
Thank you so much for that report. I just wanted to commend SMART for all the different connections and kind of creative ways that they seem to be connecting people. I also wanted to request more information about the Santa Rosa e-trolley. It's something that we're looking at doing in Tiburon, and I'd love any information that can you provide that.
On Rosie?
Yes, Rosie.
All right. I would suggest that you call this office.
Great.
Maybe even call the Santa Rosa, Sonoma Queen Power or the city of Santa Rosa, if you want the specifics of it. I personally don't have those, but
Thank you.
someone would. All right, any other questions or comments? Thank you so much. Next item is a report from the engineering status report on engineering projects. Good to see you, Ava.
Hello, good morning.
Hello.
All right. So my written report is before you, and you probably noticed that at the end of the report, there is an attachment that it's the presentation about the scope of the suspension bridge seismic retrofit. And I'll simply walk through the printed versions, and I will be referring to the big numbers at the bottom right hand corner. So on page 56, what this represents is to show that this is the final phase of the large bridge seismic retrofit program that the district initiated right after the Loma Prieta earthquake. So today, the structures of the south approaches have been retrofitted. However, what still has to be done, remains to be done, is the retrofit of the iconic suspension bridge. The whole seismic retrofit program is logistically and financially the largest undertaking that the district took on since the original construction of the bridge. So on page 57, why we have to do it? Well, the bridge is located between very close proximity to the active seismic faults. To the west, there is San Andreas fault that is about 7 miles away from the bridge, and to the east is Hayward Fault. Both those faults are proven by the past events to be capable of earthquakes, major earthquakes of magnitude above 8 on Richter scale. So the very important thing is not only that the bridge is located in the highest hazard zone for seismic, but also the design reflects the importance of the bridge that was designated to be a lightweight structure, as well as it is designated on the National Strategic Highway Network. In addition, this is a special bridge by engineering standards because it's a long span suspension bridge. So all of this compounding, we adhere to the highest standards set for the seismic retrofit, both by AASHTO code as well as the Federal Highway Administration. On page 58, and this page is not intended for anybody to memorize or
I was trying to.
It is just to show that this project will require work everywhere on the suspension bridge, everywhere in the process, on the towers. So in terms of logistics, if this project will require quite extensive access platforms and a contractor that can schedule the work in a manner to finish the job within reasonable time. On page 59, so how do we retrofit the bridge? What methods we use? One of them is to strengthen the existing elements of the structure. Another is to replace existing elements with stronger but new elements. And finally, by installing so-called stop devices, which in our case are energy dissipation devices and seismic isolation detectors. So going through slide 60 to slide 61, with regard to strengthening existing elements of the bridge, the towers require work at the tower shafts and the tower bases. What will be done is to basically add steel plates on the outside of these bottom elements of the tower, bottom legs of the tower, but also will require quite difficult work inside the shafts. Inside the shaft, the cross section was like honeycomb, basically structure with very small spaces, but still we will have to go there and strengthen the so-called diaphragm that basically provide the strength of the shaft during an earthquake. With regard to, on the right side of page 61, you can see the elevation of the main tower. And so the main tower consists of two legs connected with so-called horizontal struts. The struts above the roadway, as you can see, have this architectural facades. So during the project construction, those facades will be repaired because they are in need of repairs. The so-called strut 5 that the arrow points to is the first strut that is located below the roadway deck. And this strut will require extensive strengthening. So, going to slide 62, you can imagine during really extensive ground motion, you can imagine that the bridge truss will be required to bend and in many directions. So we want to make sure is that what connects and supports the roadway truss is strong enough to endure such an event. For this reason, all suspended rope socket connections will be strengthened. And finally, some elements of the so-called stiffening process will have to be also reinforced, especially rain connections. Going to slide 63. So all 255 beams, floor beams that support roadway deck will have to be strengthened. The way it was done, the contractor will install so-called pre-stress at the bottom of each floor beam. What this will do is to add capacity. In addition to it, any necessary repairs will be done to these floor beams to make sure that they are brought to the original capacity and condition. Also, this slide shows so-called bottom lateral bracings. This bracing will undergo extensive strengthening. Both bottom and top, so lateral brace, they are those elements that carry all the horizontal loads. So not only loads, but in case of earthquake, they have to be strong enough to carry all the horizontal loads that are parted on the bridge from the way. So with regard to the bottom laterals that are pointed to on this page 63, we estimate that this work will require about 480,000 pounds of steel added to the lateral. Then on page 64, so the way the roadway deck is supported, it doesn't sit directly on the floor beams, but when it was replaced in the 1980s, and you can see on this slide, under the pavement is really a steel deck, and that steel deck sits on so-called pedestals that are supported by the floor beams. So what we have to do to ensure that during major quake, the roadway remains connected to the floor beams, all those pedestals will have to be, all the connections have to be retrofitted, basically. And also they will be repaired as necessary if we find the loss of steel. On page 65, when you drive across the bridge, you notice that there is this, in every 50 feet, you will hear that little bump. So, because you're driving over the so-called deck extension joints, these are thermal extension joints. Unfortunately, the edges of those joints are not reinforced, and over time, under the impact of wheels, they get destroyed. So you see the little picture our bridge maintenance forces have to attend to repairing these locations very often. So what we plan to do under the seismic retrofit is to basically retrofit those thermal expansion joints by reinforcing the edges, as well as installing the joint seal that will prevent the grease from falling through down below the roadway there. Then, so which elements of the structure will be replaced under this project? On page 67, the largest work will be complete replacement of so-called top lateral bracings. These top lateral bracings, they will be the main elements carrying the seismic forces and basically making sure that the integrity of the roadway deck is maintained. Because they have to be significantly strengthened, we did cost benefit analysis, and the conclusion was that it will be better in the long run for better value and return on the investment to completely replace the lateral bracings. You see that they are basically the members like us and tires connected with bracings, but what has to be done much stronger, steel plates have to be part of those top lateral bracings to provide necessary strength. So this work will require about 3.2 million pounds of steel. And all the steel on this job is by America. So go to page 68. One of the important measures will be, right now, the floor beams are strained and prevented from off-phase buckling by those longitudinal struts, center struts, but these struts are not strong enough for the purpose of taking on seismic forces and basically making sure that there is no buckling of floor beams. So the center struts, existing center struts, will be removed. Instead, two continuous struts, longitudinal struts, that will be installed instead. Here we're talking about 1.1 million pounds of steel. And finally, going to the special devices. So we will have two special devices installed. The first one are energy dissipation devices, and these devices were designed, developed specifically for our project. They are so-called solid state because they are built of stainless steel and also thin bronze plates. This is a special alloy that during the investigation testing we ended up to select. So what happens, the way these devices work, the bronze plates are squashed between steel plates, and everything is calibrated that the movement will not occur between bronze plate and steel plate until certain level of earthquake. So at certain level of earthquake, these plates will start moving relative to each other. And what happens is this phenomena of abrasive friction, where the softer plate, in this case is the bronze plate, will undergo certain destruction. So this is how energy will be dissipated. And the reason for these devices is twofold. They are installed to limit the transfer of seismic energy to the truss of the bridge. And what it does, basically minimize the strengthening of those trusses. But it also minimizes the movement that will occur between the trusses and the towers of the pylon S1 and pylon M2 on both ends of the suspension bridge. So in terms of seismic retrofit, these are very important elements. Therefore, during design and development process of these devices, we did two-stage testing. First was a smaller scale prototype where we tested different alloys and configuration of bronze plates and so on before we set on one that performed the best. And finally, you see this little picture in the bottom left-hand corner. This is the picture of full-scale specimen that was tested in San Diego State University. And it was quite an event. And when we emerged from the lab, people were asking us what on earth we were doing there, because everything on the campus was shaking. So, and the thing is that the lab manager, he installed a fuse because he said, you know, this device has a capacity that you may ruin my lab. So we were allowed to go to certain level of forces, but to make sure to leave the lab tack, we had to stop. Anyway, in addition to it, these devices are made of very thick stainless steel plates, and there is no bolt carried in place for welding stainless steel thick plates. So what we have done, we developed a program, and we went to Vigor and PNG in Alabama. And both jobs, they were performed different types of tests, welding tests on on the type of preheat and all this stuff involved in a precision welding. So, based on these experiments, we have developed procedures for welding stainless steel plating. Right now, the Council for Stainless Steel is very interested in the outcome of our program. So, we think that eventually our findings may be the base for finally writing down some kind of a procedure for this type of work, this type of welding. Going to page 71. So when you drive across the bridge, you're of course passing over the finger joints. They are on each side of each tower at both ends of the suspension bridge. These at the ends are much smaller, but the ones next to the towers are quite substantial. The problem with finger joints is that while they have certain capacity to move in longitudinal direction to either expand or close, they have almost no capacity for any movement transversely or even vertically. So what we have done, we found that patented joint that it's not really entire joint, it's a so-called elastomeric segmental panel that you see on the rendering on this page. And this is the patented element. So what it is basically reinforced. It's made of molded rubber that has steel reinforcement inside. And this seal is capable of expansion in every possible direction. So we adding here the capacity for the movement, not only longitudinally, but also transversely and vertically. So what this does, it does restrain the trusses at the towers. And if we do not install these devices, you can imagine that there is a huge earthquake, the truss wants to move. And it's restrained by windlocks and some other elements to the tower. Basically, the truss will be wiped out. As a reminder, this is a line structure. So what we want to do is, what we want to achieve with the retrofit is to basically understand where we can expect certain damage. There will be certain damage, but the design criteria states that while you allow it, it has to be limited to the damage that doesn't impair opening of the bridge very quickly after major quake to emergency vehicles. And then these repairs can be done with little obstruction to everyday traffic. So on page 72, you will see that in addition to all this structural steel work, we estimate that we will need about 7.4 to 7.8 million pounds of new steel fabricated for this project. But one work that is included in this project is the cleaning and painting this house. And that work is in dire need to be done. So we're really looking forward that with the help of the contractor who decides the retrofit logistically, this will be possible to do with the least interruption and probably financially more better outcome. But on this page, you see that there will be some other modification done. And why we doing the retrofit of the suspension bridge? Because we have new findings about energy dissipation devices, and we found much better bronze material. We want to go back to 4-point arch, where we installed energy dissipation devices in early 2020s. And we want to basically retrofit them with new material. And also, you may notice that at the north end of the bridge, we have a seismic extension joint, but we want to take care and basically redo it in a way that it will no longer have those bumps and fells in certain locations. So, I want, in closing, I just want to point out that this project will not only retrofit the expansion bridge. If the retrofit is not done, the bridge district will have to go and work on repairs, maybe replacement to the top laterals, extensive repairs to the bottom laterals, repairs of the floatings. The facade will have to be repaired anyway. And there are many locations like those deck pedestals that they will require extensive repair. So what we're gaining here is twofold. We're making this bridge ready for work, but also we're taking care of substantial repairs that would have to be done anyway. So with this, I'll be very happy to answer any questions you have.
It appears as though we have a few. Director Curio.
So I have, first of all, I eat this stuff out.
They're all shaking their heads, and that means that they're understanding it.
I have a couple of comments and then a question. The comment is, it's a shame that Director Griswold is, because he's always worried about painting on the South Tower. But on slide 67, I had a lot of thoughts going through this, but one thought that really grabbed and shook me on 67 was looking at those laterals and thinking, that's no fun at all trying to replace those things. Because they are, when they first went in, of course, they were rigged above with the stick derrick, and you had open access to all the connections, and now you've got to pick them up from below somehow, with heavily reinforced traveler or something, I guess, and then make the connections where there's really no room to work. So that just looks like no fun, and you're doing that all down the grid. So that's a major deal, just so everybody knows. Then the other question is, as you might guess, I forwarded this immediately when I saw it, when it came out the end of last week, to Ironworkers Local 77. And their first question was, when do we get to do this? And so
It's a dream job.
yeah, and so do we have a vague notion of when this is supposed to start?
Yeah, so what's happening, as I reported before, we have on board the contractor already.
Yeah.
We are in the pre-construction stage, and we're talking about access, we're talking about logistics, how owners, iron workers will be able to go and replace those lines. Inside our design, we already have a scheme, because you can imagine replacing of top laterals. This is the primary element that carries lateral forces. So it's not like we can take one of these top lateral elements and spend 2 weeks to put a new one in. So the only two ways to do it would be install temporary lateral member, remove the existing one, and put a new one in place. But what the designer developed is a scheme where the new laterals will be installed one bay ahead. So at each point, there will be a full system of top laterals in place. So before any existing top lateral element is removed, the new one will be already there. But anyway, I agree. This job, as much as it's a steel job, steel and painting, basically what this job is about. It's very simple. But it's not so simple because of the access. So we are talking with the contractor on developing, they will be developing full-blown construction access design for the bridge, because it's not only counting the quantities of the steel or so many iron workers doing it. How are you gonna get that? right? Because this affects production rates. There is so-called working time, whatever, when the labor comes to work, right? An iron worker has to walk from whatever that initial point on the bridge is to the location of the work. Nothing gets done during that time, but we still have to account for this cost. So it is extremely important when we agree on the price of this construction that we have a full picture, what is involved and what it takes. I hope this answered question, or this is a very whiny explanation.
But there was no, you didn't get time.
When,
All the
yeah.
time. Yeah. So we plan on spending about 12 months. We started when, we started March. So we should be able to know the verdict about the price and what we agreed to next March. And then middle of next year. The thing about this job is that initially, like with previous phases, what has to be done first are field measurements and fabrication of the steel. So we do not suspect that actually the iron workers will start doing major work sooner than maybe 12 months later.
So 12 months from the 12 months, so
Yeah.
mid to 2026.
Something like
Okay,
But
okay.
there'll be some iron workers involved, field
Well,
verification.
absolutely.
It just won't be
There
a
will
plan.
Yeah, the preparatory work starting middle of next year.
Yeah.
Heavy work starting middle of the year after. That's, thank you.
I think basically everyone has had their hand up. Let's just go around. Director Duchesne?
Thank you, Chair. And just wow, and it can't happen soon enough. But just out of curiosity, I know this is a seismic record, but in light of the tragic events in Maryland, did that change the thought process of buying in any way as you went through this process? Or
So immediately after this project, we had a conversation in my department. Steve Song is our directing engineer who leads the group responsible for bridge inspections. So John and I had a conversation with Steve, and I asked Steve that we're doing underwater inspection. So for underwater inspection at the towers, and part of it, we're gonna add the evaluation of the capacity basically of the fender. And there are some other elements I wouldn't want to talk in details, but as opposed to other bridges, we at least have the fender. Let me put it this way.
So the north tower is half on land, half in the water, so a large vessel will run aground before it could strike it.
Okay.
The tower sits out in the water. The fender ring around the south tower, it's a concrete ring. You can see it right there in the
Yeah,
wall.
I was looking at
The
it.
concrete at the top is 10 feet thick, and then it flares out to a depth of 27.5 feet thick. It's 40 feet deep inside. It's about half filled with sand, so it's kind of like a giant freeway crash barrel. That having been said, in the last analysis done a long time ago, so you and your team can do a new analysis to see, what is the capacity.
And in addition to it, we were contacted by Federal Highway because they looking in whole. They want to have a good understanding how other bridges are prepared or not prepared to basically protect against this type of event.
Let's go down this side now, Director Hernandez. You had your,
No, I didn't have that. Thank you.
all right. Sorry, must have been the Red Rabbit.
I was very excited. My eyes were very
I-
big.
Yeah.
It was very exciting.
Director Rabbit.
Well, I just want to say thank you, because I think I asked for a briefing on exactly what we were doing, and I very much appreciate you doing this for us. So thank you to you, John, and the entire team. Yes. I think it's great, because I think, as we go forward, the board always acts as ambassadors for the district. Someone asks us, especially as this project gets underway, just like with the loophole median barrier and the suicide deterrent net, that we can respond intelligently. So I'm very happy about that. And as the chair of the State Seismic Safety Commission, I get a few other inquiries as well. So very much appreciate it. If we can let Dick pick out the color we're going to paint this up. That could be his contribution. But I was going to ask a couple things about how long the construction would take. Are we long enough? Are we far enough in that to understand any of the? Are things going to be outside of the normal traffic brief closures? Will the sidewalk, for instance, be closed for any extended period of time? Those kind of things.
No, we working on the assumption what you seen previously was the logistics and working nights in partial lane closures only, that this is what will be done. But at this point, we will go through a lot of value evaluations. And, you know, if we can save $10 million by doing something over the weekend rather than doing surgery during prolonged time, I'm sure the staff will bring to your attention and discuss, because we would like to have your blessing first before we take the step. But in general, what you saw on our previous jobs and on the suicide deterrent is a night work. And it's a work inside the process, so night will be used to do some work, but mainly to bring materials.
And would the tower, at one time we did talk about how the tower would be treated as it's being painted. Would it be from falls, scaffold, would it be wrapped, I guess is my big question. Tented.
Look, tents on the struts and tents in the tower legs, because you have to contain it when you remove the old paint systems. So it'll be a full containment. Managing the blast grit is a logistical challenge that's vital to how it's done.
And when you say tented, and that would be the entire structure or in pieces set up? I'm just.
We don't know yet. It's possible we will just cover everything. There is another very new development. Kalosha just announced new rules for the lab level in workers. So there is no clear direction how this should be accomplished. So this we hope we can work on this part during this 12 months. It may, I have to be honest, it may really affect the price. We don't know yet.
It will also affect how we do these activities at the bridge. It's basically a five-fold decrease in the allowed action level. And so, you know, they do what they do to protect the public. We then have to figure out, as well as contracts, how do we make it operational, and then figure out what the impacts are.
Well, I'm sure that enclosure of the tower will make a lot of news as we go forward, to say the least. I would ask about like long-term. It seems to me we're adding steel, of course, but we're removing some steel. Long-term maintenance costs, painting surfaces, those lattice, for instance, seems like that would be a pain that we'll be off and take that into account as we go forward as well.
Right. I think the experience we had from previous phases, for example, we completely replaced the towers that support the South Viaduct. This is new building maintenance because it's new steel with new paint, no lead. So we hope with the top laterals, with all these elements that will be brought new and painted without lead, it will really help our maintenance. This is a huge bridge, so our maintenance force, they do their best, but there is only so many of them. So I think the benefit of having a major bridge rehab as part of this project, it's very important to the district.
Well, just thank you. I'm glad I don't have any viscous dampers as well on the bridge, like another bridge.
Solid state,
All 40 similar metals. And the UC San Diego Shake Table, I think we're going down there, the Seismic Safety Commission, 6-story cold rolled steel building that's being built on it in 3 different ways, stick built, panel built, in modular. And of course, they're gonna shake the hell out of it, and then they get to light it on fire and then shake it again, which is, looks like a
Sounds like-
dream of
sounds like
a
a great-
2-year-old's.
Yeah.
Picture a 2-year-old on the beach with a sandcastle, and you get to do that, for a living there, so. Thank you very much for, information.
Director Hill, if you have questions.
Just one question. In 1989, I was working at Bechtel when the Lone Tree earthquake, they built the east side of the State Bridge and collapsed. And regarding the Lone Tree, it was unique in the earthquakes because it was a down and up.
Right.
It would do all of the lines of the site areas. Did you take, I'm sure you took all that into effect, the designs that you do to see longitudinal reactions?
Yes, so extensive work has been done on this project to develop site-specific ground motions. So they are specifically developed for the location of the bridge. And they account for all propagation of waves in the ground and so on, as well as account for any lateral as vertical movement of earth. So all of this and is translated into the design criteria that are specifically crafted for this project. Yes.
Okay.
And also we take into account that we are basically sandwiched between two faults.
Yeah, because you don't know what happened is it thrusted and it sheared all of the boulder, it was anchored. And this was caused it to fall. So it was very.
So the
Thank you.
design and what they did, the way it was done, there was a very detailed model of the bridge. They developed very detailed model of the bridge with accounting for many elements that have these very strange behaviors, especially when you deal with fashion bridge, how you account for its flexibility and so on. And then numerically, the ground motion were put into the model, and basically electronically the bridge model was shared.
Yeah.
And this is how we found out where the weak points were.
Thank you.
The map didn't show that, any of that, so I was asking. Thanks.
Director Tier, did I see your hand?
No, but I.
Okay. Oh, all right.
So I just wanted to thank you for your work on this. It is truly fascinating. I remember that during the 1989 earthquake, I was actually a young lawyer at a big law firm, and at the top of 345 California Street, we were on the 25th floor, and it was the first building that was on rollers. So my father had an earthquake project at university. The first question he asked me, not is, are you okay? He said, I didn't feel like during the earthquake to be on the 25th floor. So I can't underscore how these survived amazingly, whereas the major Twin Towers next to it did not have a lot of structural damage. So this work is so important, and trying to engineer something like this is almost like putting God into the future. But I want to thank you for doing all of the backup work and figuring out what will most protect our customers and our bridge. So thank you.
And I have to give credit to my staff. This is one of the jewels in the district, one of them. This is the engineering department. And also, I think my staff is very tuned in making sure we have good consultants. Because when we bring consultants on board, we want to be sure that we are in line towards the same goal. And the goal is to make the best project, the most cost effective. So really, all the awards should go to the engineering department staff. I'm just a representative.
Thank you for being their representative during the end days.
Thank you, Madam Chair. And thank you again for this great report. I was just, as we all were wrapped with on your every word, we were on the edge listening to everything you were saying, and it's really exciting. Thank you to you and your team, as you have said, they are instrumental in making all this happen. I did have a question on your written report, actually. Page 26 of your written report, where you discuss new information regarding the suspension bridge project. You refer to an open book methodology for pricing. Can you speak a little bit about what that is?
Yeah, so, what happens normally with the low bid, we normally see the list of prices, right? Assigned to each pay item. We don't know where this came from. Very often it was just imagined by the bidder. This time around, we will see the direct cost of each trade. We will see how many workers will be required for each operation. We will see how much overhead has to be signed to it. We will know from the labor agreements what the escalation of labor cost has to be. So all of this will be disclosed. And then the most important thing, our contractor will develop needs and methods, and they will be very detailed. In addition to it, they will develop full-blown construction schedule. So we will know as the bridge, as they plan to build this project, what's the labor cost, what's material, where it's coming from. We will have a special plan that the engineering will have to approve for finding the subcontract pricing and high subcontractors. We will have a plan for how to attract the most DBEs. But all of this, we will see what we've never seen before, where it's coming from. So, and then, of course, I mean, people are in business of making money. I mean, that's true. So, of course, on top of all this direct cost and cost of having the field office, cost of, using all the equipment and stuff like that, we will have to negotiate the fee that the contractor will earn. We also have to figure out who is taking the contingency, because part of this exercise during 12 months is to determine what are the risks, right? And I mean, it doesn't take a rocket scientist to know that we know the price of steel today. But in the present world, we have no idea what may happen 6 months from now, 12 months from now. Another thing is labor availability. We hope that this is such a job that all iron workers, they only want to work on this project. But if there is other activities, we don't know. And as you see from the scope, we will need a lot of iron workers to get this job done, and a lot of painters. And another thing, the risk is painters, because while Hallmark can self-perform a lot of work, they have to subcontract painting. And this is always a risk, because painters, they have their requirements. Now, another risk is this new OSHA regulation. So all of this will have a listing, and then we will price all the risks, and we will negotiate who assumes the risk. If the contractor takes it, we will allow for certain contingency to be plugged into the bottom line agreed price we pay the contractor. This may decide, I'm taking the risk of material escalation or something. If we put aside contingency, the district itself will administer. So it's a completely different ballgame. It is an open book. And I smile when we meet with the contractor, because I always tell, it's a wonderful group to work with. I mean, it's Right now, it's like everybody does the same job, but when time comes to talk about money, I told them, we are all adults, right? We'll work hard time, but we're gonna go through it. Because, it will be an education.
Thank you again, Eva. I assume that there's no one from the public that wants to speak to item, but we need to check.
That's correct. We have no speakers on this item.
All right. There's no action required on this item, but I'd like to take a moment, probably on behalf of Chair Garbarino, and she'll probably do it again, just to thank Ava from the committee. I think we feel like we're your committee, the building and operating. You try to make us smart enough to make wise decisions, of us that aren't engineers. And I hope you all understand that Ava is an outstanding outlier in her field. She's one of the few female engineers in her field. She's also the first female engineer that the bridge has ever had. She also has turned in her retirement papers, which is why I'm doing this, in case you haven't heard. She's just an amazing engineer for us. You can see that she's so deep in all of the information that she knows, and she's fair. I have the privilege of working with her, as the president usually does, with various E-team members. Just the volume of projects that are happening in the engineering department that you take control of, you make it look easy. And we appreciate that. So you'll get lots of thank yous, but I think on behalf of the Building and Operating Committee, I'd like to start. So, thank you very much.
Madam Chair, thank you so much. And this committee always meant a world to me. I mean, this is where I got my support. And I strive to make sure that you have full understanding what was presented and full disclosure.
Right.
Because only then the committee could make a good decision. And thank you for all the support this year. And I know when I came to the committee with the proposal to close the Keystone movable median barrier, I was prepared like duck under the table.
Hopefully only falling members of the bridge would have, not us.
But it went well with the help of the committee.
Of course.
Of the committee and board, and I really enjoyed that week.
Well, we've appreciated it. Thank you very much. With that, do I have a motion for adjournment? The meeting is adjourned.